Hello, good morning, good afternoon, good evening for those attending from the Far East. It's a pleasure to have you all here today, attending the last seminar of this series, which has been focused on the role of women in plant breeding. We have the honor and pleasure to have with us Dr. Jolien Swanckaert, who is a potato breeder at Ardivo. Ardivo is a joint venture between KWS and Simplot. And her role there is to transform potato breeding from a clonal crop into a hybrid seed propagated crop. So she's developing hybrid potato pipeline at the diploid level, tackling inbreeding and depression and extensive hybrid testing in Europe. Jolien has her studies were mostly between the University of Ghent and ILVO, the institute associated with the University of Ghent, and she did a bachelor in bioengineering, then a master's and PhD in plant breeding. With also she has worked at CIMMYT and SIP, so she has extensive international experience. She's originally from Belgium. She works in the Netherlands in a joint venture between a German and a US company. So that's very interesting. Jolien, it's a pleasure to have you with us. And I'm gonna stop sharing here and give you the floor.
Thank you. It's also a pleasure from my side to be able to talk about my work. It's something I like to share. So thanks a lot for having me today. I will share my screen and start the presentation. So that should be okay. Okay, so
Not yet.
No?
No, not yet. I don't see it. Oh, don't worry.
Oh, wait. Yeah, no, I see what I did. Yeah. Now starting up. Is this okay?
Yes, it is. Thank you.
Okay, great. Thank you. So yeah, I will be talking about breeding for diploid hybrid potato, and we call it the art of potato innovation, because you will see how it's different from the conventional potato breeding, what has been done over the many years in the past, and now trying to look at it from a different perspective and bringing knowledge from well-known companies together and developing something new. So I will talk a little bit about myself and to show, from where I studied up to where I am today, and then talk about potato, what we're looking for in the crop, and then going to a more insight on the breeding parts about diploid potatoes, hybrids, and what that means, and what we are really working on here. So I give you some insight in the transition from a clonal crop to a hybrid crop, and what that means on the breeding side. So to start off, so I grew up in Belgium. I grew up on a small farm. I think it's a bit hard to imagine that from a US perspective, but when I talk about small, then I mean about 30 cows and having a bit of land around the farm just for own production. So it's a nice setup in Belgium, where you have these family farms running. So now I live in the Netherlands, and I spend my time in the garden. I like to go swimming, and I also have 2 girls, you can see in the picture, and we have a 3rd one on the way. So it's really exciting times for me. So I like to connect with people. I like to work with different cultures, and I had the opportunity to do so in the years from my studies up to where I'm now. So I really like to see how we bring those different cultures together, and we can work on a global scale in the food production or the agricultural sector. So I started in Belgium, where I did my master degree. then moved on to a PhD at the same university together with ILVO, which is the Institute for Agriculture and Fisheries Research. I did my PhD on maize, so it's a little bit different than what I'm doing right now, but it gave me the start of plant breeding and to get a taste of what that means and how to get into that domain. So after my PhD, I was able to work for SUP, the International Potato Center, and I moved to Ghana, to West Africa, as a postdoc sweet potato breeder. Then moved within the continent, so I then moved to Uganda to continue that work. And then, unfortunately, we all had to experience the troubles we had with COVID, and that actually led to my decision to come back to Europe. So I've been here since 2021, and now, I was hired as a hybrid potato breeder in the Netherlands, and that is what I'm currently still doing. So I will tell you about this job and also link to the experiences I have been able to build up here in the Netherlands. So when I think about plant breeding, I wanted to take a step back and to maybe talk a bit about what is my experience in that, from studying plant breeding up to actually becoming a breeder. So my time is actually mostly spent on a couple of things. So we are working on a breeding strategy, and that means that you need to think about the future, what's coming up. What is the market going to need in a couple of years from now? So it's a strategy that needs to be able to run for a longer time, because breeding takes time. It's not about results in the next year. It's about what do we need to have in 5 years from now, in 10 years from now. So the strategy is really putting those pieces together to say, look, we know the genetics, we know what we need to do, but it's how to translate that in actual breeding activities. What do we need to do? We need to have field trials, we need to have crossing blocks, and how do you put that together in volumes and planning and building a strategy around it? Then most of my time goes into operations. So I think that's, as a plant breeder, it's very common for to have a lot of time spent on operations. And that means that the things need to run smoothly. So there are crossings that are done, there are field trials to run, to take data, and so on. So how do you do this? The operations is about working together with teams that are also taking or translating what you had been describing in a strategy. How do you translate that in actual trials? So there's breeder is strongly connected to the operational team. Breeding is also throwing away. I think that's a general message I got from my professor, and it's nice to bring that here as well, is that as a breeder, you work with a lot of material, a lot of things, and actually the hardest decision is maybe to throw away stuff. So that means that there is no going back. So once you decided, I'm not interested in that part, you throw it out and continue with the part that you want to continue in. So it means that, it's sometimes very strong decisions you need to take, saying, look, this can go. Because we're working with huge volumes, and it's just not possible to keep everything that might have some possibilities in the future. So it's being strict about that. But when you throw away, you also want to maintain material. So it's about keeping, knowing what to look for, and then having that germplasm continuously maintained. Because we're working with plants, we're working with perishable material, tubers, pollen, and other plant parts. That means that when you want to have a cross later on, how do you keep these interesting genotypes? And you need to come with a plan to maintain the germplasm. Breeding is also about data, and a lot of data collection. There's many things you can measure, and then it's about processing that data, using it in the right way, and also on the right time. So it's when do you make selections? What kind of data do you need to make that selection? And making the right choices as you go on in the programs. And planning is a big part of it. So to know what do you want to achieve and how you want to achieve it. You work in bigger teams, so it means that the organization of that requires a lot of planning. So that's in general for me the most important parts when I want to describe my job right now is how do we deal with it. So these things are very important. And one thing that always comes back when we look at those activities is you always need to question, who are you breeding for? What is the market? How is it going to look like in 5 years from now? So you can anticipate on that. So when I ask this question, then I think about the potato market. So what kind of products are available? What kind of products do we want to breed for? So I'm showing some pictures, I think mostly Europe influenced, but we have the fresh table market, the French fries, which come in different packages. So you can have frozen, pre-processed, but also freshly French fries, and also the QSR market. So it's the McDonald's. You can think of these kinds of different market segments. There are crisps, starch potatoes, so that requires a whole set of different traits in a variety, and the flakes. So once we know what we are interested in, what kind of product we want to breed for, and who do we want to breed for, then we can start organizing that. So like I said earlier, a breeder is part of a bigger team. So we are dealing with a lot of moving pieces. So, and all of them have to move in the same direction and the same speed. Otherwise, you will not be able to make progress as fast as you want. So it's about sharing data. It's about planning, and how do you bring those pieces together to make the best choices. So we talk about phenotyping, genotyping, agronomy, and data management, I think, are the key components in that. So we have, there's a lot of research linked to it as well. So it's not only putting it in practice, but if you look at genotyping platforms, what kind of possibilities are there, and what kind of research is needed to use it in an effective way. So then I would be thinking about mapping populations, or I would think of different understanding of the genome, and reaching out to different people to make sure this is all coming together, and in the way that you wanted to have in your breeding programs. So then, looking at a potato plant, what are we looking for? So first, as a breeder, we want to make a cross. We want to have a fertile plant. That means that the crossing, so the male and female fertility is important for crossing. But on the other hand, when we look at the product in the field, the seed is not wanted in the field, because then it can lead to volunteer plants having to deal with potato as a weed in the coming year. So we need to balance that trait. So of course, if you can't make a cross, you can't use it in later generations. But on the other hand, fertility can be an issue when we look at the product. Then above ground, we also see the development of the plant. It has an impact on how the plant is grown during the season. Then we think about different traits, for example, emergence, canopy closure, nitrogen use efficiency, water use efficiency. So that's all linked to the development of the plant. And in the end, you want to have good yield. And the yield is what we don't see the yield only at the end of the season. So above ground is only a way of getting to a better yield. So we want to keep the plants healthy. We want to have built-in resistances. We want to make sure that the plant is senescing on time. But it's all in context. So it's only serves as a mean to produce more tubers, because in the end, our tuber is it will become our product. We want to have good potato yield, uniformity in yield. So that means that the size of the tuber is important. The tuber appearance in general. When you buy a potato in the market, you want to, people have a preference for the skin, that the color even is looked at. But these are all traits you can say, maybe you can rank those traits, right? So it's about putting them in context and having them as a package together. So for us as a company, a breeding company, we are focused a little bit more on the processing side. So it's about having no sugar ends, no darkening after cooking. Dormancy is important. So you can see that the different parts of the plant, there's different traits that we measure, and we want to make sure it all comes in one package, that you have the ideal potato plant as a new variety. So how do we describe those traits? And I want to highlight here that there is a crop ontology that is universal or globally defined. And this is, you can see that it's led by SIP, the International Potato Center. You can look at different potato traits, what is measured, how it's measured, and to standardize across the different programs. And it also helps us in a private company to standardize and to share data. So the crop ontology is a way to compare data over time, but also to compare between different countries and to standardize what we are measuring and how we are measuring it. So this is accessible. If you go to the website cropontology.org, you will find the way these things are described. Not only for potato, it's the ontology is for every trait. It's there. I just wanted to show for potato there are different traits linked to different aspects, and abiotic stress you see, but also a lot of quality traits, post-harvest, and so all of those things we can measure, that we can evaluate in a variety or in a new genotype. When you go through the list, there's a lot of things you can describe, and as a breeder, it's not possible to have all of them included in a selection in 1 year, for example. So that means that we make decisions on what traits are now more important to have and which come maybe later on, that as long as we monitor and we see that they're not going in the wrong direction, then that's fine. So we try to prioritize the traits to make it more feasible to have products out that at least score good and certain basic traits, and then using the other traits to describe how the material is performing. So we at Ardevo, we don't have a tetraploid potato breeding program, but I want to start there explaining how it's usually done, so that you can see and understand what are the changes and what I'm talking about, how it refers to the way it is done right now. So in a traditional program, you would start with a cross, so two parents that are interesting for certain traits. You want to combine those in one cross and create more genetic diversity to select from. And you can see in the scheme that there's every line is 1 year extra. So it takes quite long between making the cross and selecting the variety, the candidates for registration as a new variety. So that means that the first time you will evaluate the new genotype, you only have maybe one plant to evaluate. And one plant is not sufficient to see all of the traits that you're interested in. So we need a couple of years to multiply that material and keep on expanding. So in the second year, the one plant becomes a plot, and you can already measure some traits on that. Based on that, the selection continues. The number of candidates decreases, but you get more and more information about how that genotype is performing. And then, so the process takes a couple of years to really get sufficient and accurate data about the genotype so we can select and come with the best candidates at the end. By doing so, the cross that was made in the beginning and the genotype that was evaluated in the beginning does not change genotypically during this process. So what you start with is actually includes your potential variety already. So nothing changes on the genetic side. It's only that it takes so long to get sufficient material for evaluation and to get sufficient data to bring or to collect enough information that you're sure that this will become a success later on. And once you know that, then there's a need to multiply for commercialization, but I will talk about that later. So the traditional breeding companies in Europe, we have, especially in the Netherlands, some very strong companies that are having a global presence as well. And in the US, I got this slide from a US colleague. There's a lot of public sector potato breeding going on, and which links to a lot of research in potato that helps us understanding about the physiology and other research areas in potato. So it's very good to know who is working on which domains to further make progress in the genetics and the general development of the plant. We are here in North Carolina right now, so we have the group led by Crediencio that's working on potato, but you can see that all over the US you have different teams contributing. Then I will continue talking a bit more about our setup. So Ardevo is a joint venture, like I mentioned before, between KWS in Einbeck, which is in Germany, and Simplot in Boise in Idaho. So we are quite young company, only started in 2018. We have our headquarters in the Netherlands. So it's quite interesting how this was set up. And Ardevo is actually a combination of Dutch words. So we have aardappel, potato on one hand, and an evolution attached to it. So there's a meaning to that as well. You can see the picture here in the Netherlands. So we are working independently, and we can use the experience and capacities and the network of the two mother companies to build our own expertise. So KWS is a known hybrid breeding company. It has a lot of experience in other crops, not so much in potato, but especially on hybrid breeding schemes. They're very strong. They know how to, it is also a seed company, so that helps us to develop potato as a seed and how to use that knowledge in breeding to transition potato from a clonal crop to a seed crop. That's here in Europe. And then in the US, we have the team at Simplot, which is very strong, which has very strong knowledge on food processing. That's where we are linked to, but they do many other things in agriculture, and they have a very strong presence in the US and in other parts of the world. So this structure helps us to bring the hybrid breeding knowledge from cradle with, and the processing, the fries and frying expertise from Simplot, all together here to create a variety that will be good in the processing market. So for Adevo is specifically focused on processing, and in that path that we take, we need to work on a few transitions. So it's not only one transition. We're not only changing from clonal to seed, but also on the genetic side, we are transitioning on a different levels. So first, we are going from a tetraploid to a diploid. I will come back to that later, why this is a necessary step to make a hybrid. We are going from outcrosses to hybrid breeding, so making inbred lines and hybrid breeding. And then at the end, once everything is fixed on the genetic side, we can move from a clonal propagation to a true potato seed.
Jolien, sorry to interrupt. Can you click hide on that little sign there that you have on the screen?
Oh, sorry.
Thank you. That's it.
I did not know you could see that. Yeah. So before I continue, I want to explain a bit what TPS means, because it's something new. In a traditional potato crop, you would never pay attention to it, let's say. Yeah, the berries, the seed, it's a side product, but you don't really want it to have as a consumer or as a grower, let's say. But for us, it will become our product. So we are selling seeds in the end. So true potato seed is the abbreviation of TPS, is the botanical seed of potato. And this has been introduced in the past by SIP and by others, but it has never really taken off as an alternative way to clonal multiplication. And the most important reasons are the lack of uniformity. When you start using TPS, you get a mix of the genetics of the both parents, and it's still on a tetraploid level. It can go either way. You can get very underperforming plants and good plants all mixed in one seed lot. So that was one of the reasons why people don't want to start using TPS. It has a lack of quality, and that is linked to, in a seed, you don't know what is in there. Every plant can be different. So it was not optimized, let's say. But when we can optimize through a hybrid system, there are many advantages by using it. So through seed, you have a limited risk of transmitting diseases, at least not the ones we know that are transmitting through tuber. These will not be of any importance when we start using TPS. It's easier to store. You can keep TPS for 5 years without a problem, and transport becomes much easier. The other advantage is that you have a faster variety multiplication. So it means in seed production, if you do it properly, you can get easily thousands of seeds on one plant. Thousands of seeds means thousands of plants in a field. So the way of multiplication can be handled on a different scale. But when we talk about seeds, I think it's important to also understand the implications. We will sell the fruit of the plant, but in the end, our product is in the tuber, right? So we want to make French fries, we want to make crisp out of the tubers. So as a breeding company, we want to optimize the seed production, the TPS production, but without compromising the quality of the tuber. So we need to look at the balance between the plant, what that means if we are putting a lot of pressure on seed TPS production, how does it translate to the number of tubers, the quality of the tubers, and the processing of those tubers. So that is, if you compare with other crops, as an example, you could take corn. With corn, you want to have, you can use the kernels as planting material or as a product to process. So it's one thing. So what the breeder needs is also what the consumer needs, and that helps to breed in a certain direction. So for us, it's two different things, and we have to be aware that if we increase the other, we need to keep the quality of the product in mind as well. But we cannot do one or the other. It has to be both. We need to produce these seeds, and so the balance has to be right. It cannot turn in one direction or the other. In a traditional system, the seed multiplication is done clonally. So you have certification in place here in Europe, but also in the US, going from pre-basic seed tissue culture to the certified seed. And that takes a couple of generations, so a couple of years, and every year the classes are downgraded. So it means that every year you multiply, there's a higher chance to get infections and to spread disease, and that's not something we would like to see going out of hand. So this classification system is in place to really use healthy seed, and there's a whole sector looking and taking care of this, that we are not spreading diseases easily. And in the Netherlands, this means that the seed potatoes are produced on nematode-free land. So there's quite a lot of restrictions on how to produce seed potatoes and where to produce them and so on. It also means that it takes quite some time to go from a couple of hectares in seed potatoes to the numbers or the volumes you need for a ware crop. It takes time. It takes also the space, the area where we need to produce them on the field, and there's a whole logistical effort to ship them around the world. Just to give an indication that how the system works, so you have a couple of years seed potato production. They are planted much closer together, so you need quite a lot of seed potatoes per hectare to be planted, and then you harvest those plants early on. They're spaced closer together, so it means that they're smaller tubers, and then this is sufficient or fits the need as a seed potato for either going into a next round of multiplication or going to a ware potato crop. And then you have growers to do that, and then there is a consumption farmer that's then harvesting potatoes, going to processing factories and so on. So there the spacing is a bit larger, and so here the tons per hectare really counts. You want to have sizable tubers that are really yielding quite a lot, and then can be used in the processing industry. So if we look at that scheme, we are convinced that the first part, the seed potato production, can be done differently. So we can start from TPS or transplants, for example, to produce seed potatoes and then go to a ware crop the year after. So the second part would not be changing as much. It's about how to grow those seed potatoes from TPS, and that is the change that we envision. Then about our journey in Ardevo, how do we make that transition? How do we go from a tetraploid breeding company or to a seed company? So first we collect look at the material that's available on a diploid level, but you can also create diploids from a tetraploid, and I will show you in the next slide. But these first diploids are not that great, let's to be honest there. So we need to select for the performance, the yield, agronomics that we want to have, and that takes time. So we are evaluating and crossing and just building up that performance that we lost by reducing ploidy level back to the level that we need. So we can have a diploid genotype or diploid variety that's on the same level as a tetraploid standard. We need to select for fertility and seed traits, which is what I explained earlier. It's important to have that balance, to have enough seed produced, because this will become as a breeding company, our product, and we need to make those crosses work in the program. And once we can do that, we are working on a diploid level. We still need to take steps towards line breeding, creating lines, and then hybrids. So we are facing problems with inbreeding tolerance, and then and having inbred lines from that. So the process we are now, or the journey we are taking right now, is actually rebuilding that germplasm on a diploid level. And if you look at how in the last years from a tetraploid company breeding perspective, we are still re-domesticating, as you can say, to have the same level of performance on a diploid level. So how do we do that? How do we go from a tetraploid to a diploid? So this is well described in the literature. You can find it there as well. Is that there's a Furea wild species that leads to a prickle pollination. So that means that it induces the ovules to become seeds, and so you make a cross between your tetraploid that you want to have, that has the interesting traits, and the Furea as an inducer to create dihaploids. The advantage of using Furea is that it has a specific phenotype. It has a lot of anthocyanin, and also in the seed itself, you can see visually the anthocyanin in the as an embryo dots in the seeds. So when you see these spots, then you know that the cross was actually made and that the genes of the Furea were crossed with your tetraploid. And that means that, it's something you're not interested in. So we're looking for the seeds without the dots, because these do not contain the genes of Furea. And from there, this is all done in vivo, so we can grow out the seeds and start evaluating the dihaploids. So in the last years, we had a lot of questions whether diploid potatoes could yield as much. There's a reason why we work with tetraploid varieties, let's say, in the commercial world. But we have proven that in the last years we have shown that the diploids, by recombining, selecting through the breeding process, can reach the same yields and the same agronomic traits, quality traits that we are interested in, and that we can compare with the tetraploid checks. So let's say we have resolved that issue. All our material right now is diploid, so we don't have any tetraploids anymore. The other issue with the dihaploids is the male fertility and the lack of vigor. So for male fertility, we see that it's linked to cytoplasm. So we have different types, and so there's cytoplasmic male sterility present in potato. It might be useful at the end when we start making hybrids, but at this level, we want to make crosses between those dihybrids and start using them. So it's something to overcome. Also, in potato, fertility has not really been an issue or not a key criteria for having good, key criteria to select good varieties. But for us, we need to bring in male fertility. So there has been some work done on finding restorers and to get fertility also back into our germplasm. Inbreeding depression was mentioned shortly, so we do see that by first going from tetraploid to diploid, that we see weaker plants, we see a lot of strange behaviors, a lot of root systems that are looking wild. So it's mostly linked to inbreeding depression. So there are deleterious alleles that cause those defects, and they are becoming more visible when we look at the diploid level. They might be they are in the tetraploid as well, but because you have 4 copies of the gene, they are not as visible there. And they stay there when people are crossing and selecting the best varieties in that material. But we do see them back when we start working on a diploid level. And we see them even more when we start creating inbred lines. So I took this picture in the field, and you can see that this plant is trying really hard. It has a lot of very tiny tubers developed in these roots, but this is not a phenotype that we are interested in. But again, through breeding to select against it, we can overcome inbreeding depression. I'm convinced that even in potato, we can make completely homozygous inbred lines and to be able to produce a uniform hybrid. But it's a very strong bottleneck we need to overcome. And this also, it takes many years to select, to further make progress on the genetics here. So you start seeing more and more of these papers coming out about inbreeding depression. People work more on diploid potato and how this is measured and how this is visible in the different development stages of the plant. So I talked about inbred lines. So that's here I took a scheme from the KWS website. So it shows you on one side that you have an interesting diploid plant. You start selfing, you're trying to fix the traits in the mother plant. And then on the other side, you have another genotype that has maybe other traits that you want to have. So you fix those in the inbred line B, and if they're completely fixed, you can make a cross between the 2 inbred lines and have a very homogeneous hybrid in the end, and also a very heterozygous hybrid. So that's by looking at the combining ability of the 2 parents, you create the heterozygosity back in a uniform way. So that's then your F1 hybrid, and that will become our product to sell. So we can have seeds that are all genotypically the same, and that will lead to a uniform crop. So are we able to do that? And so we put together this nice picture. It's only not a real cross. So this is what we envision, let's say. We think about this as where we should go. The inbred lines can be ugly, and they will be ugly from now. Maybe they will get better over time, but you look for certain traits for example, the length of a tuber in one parent, and you look for other traits in the other parent. So you want to have the trait package and the whole set of traits in your hybrid. That means that you can actually split up the traits and make them complementary in your two parents. So it means that all your inbreds line don't need to have the whole trait package. So they can be they can be good for certain things and not for others. But by combining it back into a hybrid, you want to have them available in one variety. And that is a key difference with what you can see in the traditional breeding, because there, when you make a cross, you are looking for the whole trait, all of the traits you want to have into one variety, and that needs to be the output from a single cross. Here we can look at complementarity and then build up these traits into one at the end. So then we when we can make a hybrid, we can make seeds that are uniform, that are genotypically uniform, also phenotypically uniform. We still face a lot of practical questions that are different from a traditional system. And then there are different domains that are opening up for research, for example, the seed physiology. So how does germination affects or what kind of variation do we see in germination, how it's growing during the season. When we use transplants, how do we grow them? Do we grow them in the greenhouse and then transfer to the field? How do the plants adapt to that? And how do you get a good way of new way of seed growing for potato? So there's a lot of research linked and agronomics that needs to be figured out to set up the system. So I've talked about the breeding part, so we know how the genetics works. We know we can get there. It takes time, it takes a lot of resources, but we make progress and we can see that we get more uniformity out and we can get those traits that we're looking for. We are making progress in that direction. So now we need to complement or make sure that on the agronomy side, we are following that so we can come with a recommendation, say, look, we have a good hybrid, this is how you can grow it, and this is how you can have a new way of making a potato crop. So we're making a lot of progress, and we have a whole team to support on this, and there's so much more we need to learn every season. We face new challenges, and we need to come up with different ways to tackle them. But I'm really hopeful that in the coming years we'll get to a product that's both on the genetic side really good, and we can come with some recommendations on how to make the fields work and to grow them actually. So TPS, it's not new. It's even 40 years ago was already talked about that TPS is a part of the future, and we strongly believe that this future is not too far from now. So I want to end here, and just to I hope you got a bit closer look at what we do at Ardevo, and we will work hard to make this a successful story.
Thank you so much, Jolien. I see you're having a lot of fun, and that's what breeders are about, isn't it? Thank you so much. We have a lot of already questions and comments. We want to stop sharing the area. I'm going to start with a question from Jim Lawrenson. To what extent you're using testers at this time? Are you building genomic pools, complementary pools using markers? And also, what is the intended cell of the TPS is the final grower, or is an intermediate grower that will grow the TPS and produce more tubers for sale?
I'll
is
first
the
answer
process?
the second.
Yeah.
So what we envision is that the way potatoes are multiplied and the seed growers are working, that we can change that first, that we can condense that in 1 year to grow from TPS, scale the production in TPS production, but only having 1 year of multiplication to get enough tubers ready for the ware crop. So that's our first idea. We think on the longer run that you can squeeze that in 1 year, that you can grow from seedling or TPS directly into a ware crop. But we also know that there's going to be more challenges to that. So I think to be realistic, we will introduce the hybrid varieties as in 2 steps first, as we follow the current system a bit more closely. And then the second question about the testers. Yes, we are looking at the different pools, how they complement, doing GCA testing on that. We still do a lot of crosses by hand, so there's a manual cross, and that means that we are not restricted to only a few testers. If you do it by hand, you can pick as many males you want to make the cross. So we are still first trying to see across the whole germplasm pool how the complementarity is fixed, and then setting up a system towards testers will come later.
So a practical question, I would say, how many seeds you get from one pollination in potato?
Say that again, sorry.
How many seeds in average you get from one pollination in potato?
It varies a lot. So this might become a selection criteria as well. So you can have 0 up to 1,000.
Yeah. Okay. So I'm looking at some. I want to pick. Sorry if we don't get to address all the questions. Okay, but talking about molecular markers and what are the tools that you use and how do you integrate into your program, and would that help you shorten your breeding cycle? As I'm summarizing the question.
We do use a lot of marker data, especially because we have close access to the labs in AMAC and KWS, which gives us a much stronger position in that. So we use it in different ways. So first to check the genotype. So it's, when you move around material, especially clonally multiplied, then you get different handlings. So we use markers to check whether the genotype is still what it's supposed to be. We use it in selection. We use it for our pre-breeding, mostly to look at resistant genes. So it's an integrated path, let's say. So that's why I started with the presentation saying that there's so many things going on and so many people involved that you need to have market data on time to make the right selection decisions. And it's very important to bring that together.
A question from Paulo. How are you incorporating the trends in climate change into your program? I mean, is it influencing your decisions?
Yeah, we think that TPS will be more future-proof. So we can see the advantages of having to start with from TPS compared to clonal, what is happening now. Of course, the environment that you're testing, we see a lot more extreme weather conditions, and so we're developing a new way of growing potato, a seed potato, and taking into account what it needs to have to be future-proof, so to be resistant to these extreme weather conditions, and how can we adapt our methods to that. So that's more on the agronomic side of questions. And the breeding, yeah, we look at maturity, how long is the season, and how can we adapt to what we have, the conditions we have right now, but also knowing that it will become, it will change over time as well. And we taking into account the changes in legislation, so we have less herbicides to use. We have other factors that are need to be considered as well. So it's like I said, we are breeding for 5 or 10 years from now. So we have to be able to include that all of those aspects when we make our selections here today.
Is your target mostly the developed world, or you're also aiming at the developing world and how to collaborate with, for example, SIP?
So we have a strong focus on Northwest Europe and the US because of the background, KWS and Simplot that are supporting us. So that's our first target. But once the system is set up, once you have inbred lines and you have hybrids, there's always opportunities to start testing in different environments as well and include that. But just to give you, the context that we're starting up, we're still building those basic profiles. So there's still a gap in yield, there's a gap in quality traits. So we need to fix those gaps. And once you have the basic, then we can look at what environments and to see, look at different markets as well.
I saved this question for last because of the intent of this series. I think it's very appropriate. And the question is, given how time-consuming and demanding plant breeding is, have you faced any challenges in your journey as a woman in plant breeding with respect to work-life balance and how you have overcome it? I think this is a good question to end a series that is focused on women in plant breeding.
So personally, I think I was very lucky where I ended up with. I think I was very lucky to be able to work at SIP and to start my career in sweet potato breeding in these African countries, which it opened my eyes a bit more on how the cultural differences, but also how, as a woman, you are perceived in this or in this world of plant breeding and let's say potato breeding. But I think it doesn't need to be negative, right? So it can be, you can show that you have your skills, your experience, you can apply it. So you can gain that trust, and you can really build a career there, even in a global world as well. When I'm here in the Netherlands, we are connected to the US with Simplot and so on. So it's less visible, I would say, because I think there are a lot of laws and perceptions around women that work and that are doing agricultural work. So it's less visible here for me in the Netherlands than it was when I was working in Africa. But I would say don't let that intimidate you. Don't let that be a limitation. I think, there's access to courses, there's access to networks and things. So it's fine to build that network and to really become successful in plant breeding as well. So I think it's for sure feasible.
A rewarding career, as you say. Yes.
Yeah.
Thank you so much, Jolien. It's been a pleasure to have you in this series, and thank you for everybody that have participated in this series. I'm always excited to see how many questions and the range of participants. We conclude this series. There will be a new series started in March. I would certainly encourage, if some of you in the audience would like to present your research, please contact me, or if you have suggestions about potential presenters, please do that. We're always on the search for that type of international presentations. Thank you so much for your attendance. I would like to thank Brandon and Tiago for their help in organizing this seminar. Have a good holiday and look forward to see you next March. Thank you so much. Thanks, Jolien.
Thank you. Bye.
All right. Bye-bye.